let's review exponent rule in this video. So I wrote down all the basic exponent rules that we will need for this class. So let's start with product rule. Product rule for exponents, Product rule for exponent says for any real number a, okay, and m, when the base are the same and the base are multiplying, we simply will add the exponents. Okay. When the base are the same and the base are multiplying, we will add the exponent. But take a look right here. These exponent rules are used for one term only. Multiplication here indicating I only have one term. So if there's a plus sign here or minus sign here, then I cannot use the exponent rule. Use any exponent rules, basically. Okay, so every one of these notation I wrote or the formula I wrote is for one term only. So when the base are the same and the base are multiplying, then we will add the exponent. So real quick, let me get my pen ready. Real quick, before I do this example, negative 3x to the third, let's take a look. What is the difference between x plus x versus x times x? Well, x plus x we know is going to be 2x, x times x. All right. When the base are the same and the base are multiplying, we simply add the exponent. So x times x means x to the first times x to the first. So when we add the exponent, it's x squared. 1x plus another x should be 2x. So other than the answers are different, what is the difference between these two problems? Well, the key difference between the two problems is addition sign here separate between two terms. So this is actually combining two terms versus the multiplication sign here actually means this is only one term. Okay. So we think this one term, if the base are the same, we can simply add the exponent based on the product rule here. Okay, so one term problem, we do it differently compared to multiple terms type of problem. Okay, a lot of students will say x plus x is going to be 2x squared. Well, this square up here is incorrect because I'm not adding the exponent. And why I'm not adding the exponent? Because I'm not multiplying. Okay, so combining two terms, when we combine like terms, we simply add and subtract the coefficients, but we don't do anything with the exponents because the exponents are used to identify that these two are like terms. So if I have a 2x squared plus x, these two terms are not like terms because one of them has exponent 2, the other one has exponent 1. To be like terms, you got to have the same variable and the same exponent in order to combine them. So we cannot say x plus x is 2x squared because the exponent is used to identify the two terms are like terms. But that's very different compared to multiplication. Multiplication is only one term. Okay, so one term problem is different. We do it differently compared to multiple term problem. So negative 3x to the third times 4x to the fifth, this is a multiplication. So this whole thing is only one term. So all we do is basically just multiply. The negative 3 times the 4 will give me negative 12. When the base are the same and the base are multiplying, we simply add the exponents. So that will be negative 12x to the 8. Okay, don't be like multiplying the exponent too. Okay, that will be incorrect. Multiplying exponent will be the power rule that's written down here. Now, quotient rule. Quotient rule says, for exponent says, when the base are the same and the base are dividing, so division is also one term, we will subtract the exponents and always take the top exponent subtracts the bottom. Okay, so subtraction of exponent is the same as cancel them out. So a quick example here, let me use this a to the 4 and a to the 7, okay? A to the 4 means a times a times a times itself 4 times. A to the 7 down here means a times itself 7 times. 1, 2, 3, 4, 5, 6, 7. So the subtraction of the exponents simply implies cancel them top and bottom. Okay, so that's why a lot of times I will say if I got 4a on top, 7a in the bottom being multiplied, when I cancel them out, or when I subtract the exponents, how many a should be left? Clearly, you can see there should be 3 of them left being multiplied in the denominator. Okay, a times a times a is left, so that's a to the third. So once I canceled out everything up top here, that should leave me with 1. So 5 over 35 is going to be 1 over 7. So that means all my numerator got canceled out, so the only number left over is going to be 1. So my answer here is 1 over 7a to the third power. And the reason why I'm able to cancel them out like this, top and bottom, because my whole entire numerator is only one term. Okay, denominator is also one term. We can only cancel out top and bottom like this inside a fraction if the both numerator and the denominators are one term over one term. Okay, can't just say if I have something like a 2 plus 3 over 2 plus 4 and you say 2 and 3 cancels out. Okay, say the answer is 3 over 4. Okay, that's just very wrong. Because the reality is the answer is actually 5 over 6. All right, so just be careful. Got to make sure the numerator and the denominators are one term over one term before we can cancel them out. Negative exponents, all right? If my base has a negative exponent, we normally just flip the base to the other side of the fraction and make the exponent the same. Then make the exponent positive. And vice versa. If I have, for example, a base that has a negative exponent, so let me just say 1 over a to the negative 2 power. So if my base a down here has a negative exponent, then I will need to flip it to the other side of the fraction and make the exponent positive. So my a squared now is actually on the numerator. See it as over 1, but we don't write over 1 if there's nothing else in the denominator. Okay, so got to make sure who has this 8t to the negative 2 power. You got to make sure who has which base has a negative exponent. So 8t to the negative 2 power is only one term, consists of two factors, an a and a t. So this 8 actually has exponent that is positive 1. The t is the one that has negative exponent. So only the t will need to be flipped to the other side of the fraction. So once my t comes to denominator, then the exponent will become positive. So the 8 got to be remain on the numerator, all right? Because the whole problem was over 1 in the first place. Now, later on the semester, we will also talk about having a positive exponent, right? And then we might have to flip it back to the other side of the fraction. So if I ever need to flip any bases to the other side of the fraction, okay, my exponent will actually change the sign. So if I ever want to flip this t back to the top, then I would be t to the negative 2 power. I got to switch back the sign on the exponent. Okay, so we will do something like that later on the semester. All right, power rule. Power rules are multiplication of exponents. Okay, the power rule A says for any base a, for any real number a, if the a is my base to the n power, but then the whole thing to an n power on the outside, then we will simply multiply the exponents. Here's the reason why. If I have 2 to the third and the whole thing being squared, focusing on the square on the very outside, the parenthesis, if that's the exponent I'm looking at, then the entire 2 to the third that's inside the parenthesis, which is actually my base, is actually time itself 2 times. All right, so now once I write them out like this, each 2 to the third implies 2 times 2 times 2, 3 times. Another 2 to the third is 2 times 2 times 2. This multiplication right here allowed me to continue to say I got 6 2's being multiplied. Okay, so instead of doing all this, the power rule simply says if your base is raised into a higher exponent on the outside, all we can do is simply multiply the exponent and say that's 2 to the 6th power. Okay? So let me go ahead and explain this one right here so we can do both example, okay? All right. Power rule B says if I have two different factors or more than one factors inside the parenthesis, then the outer exponent will actually distribute its power for or multiply all the exponents, okay, that are in the inside. All right. Now, keep in mind, this is A times B, so that means I only got one term inside the parentheses. So right now, inside the parentheses is one term. Each base or each factor has exponent 1. So by the power rule, the outer exponent n will multiply both of these exponents. So that's why I get a to the n times b to the n. So let's look back on this parenthesis 2x to the negative third power whole thing squared. All right, so I got 2 and I got x as two factors inside the parenthesis here. The 2 actually has exponent 1. So when my outer exponent 2 start multiplying all the exponents in the inside, 2 times 1 is 2. So that means my base 2 is going to be to the second power. The x will now be to the negative 6th power. So this is a lot like distributions, okay? This is a lot like distributions, except I'm multiplying the exponent so I can bring all my factors to the outside the parenthesis. All right, we know 2 squared is 4. My base x has a negative exponent, so we write everything as a positive exponent. So this is going to be flip it to the other side of the fraction. So the x will come to the bottom, the exponent become positive. The 2 squared will remain on the numerator, which is 4. So that's my answer, 4 over x to the 6th power. So once you realize inside the parenthesis is only one term, then all you got to do is take a look at how many factors, okay, are inside the parenthesis. Because each factor, okay, once they come out of the parenthesis is viewed as separate base. Right now, if I'm focusing on the square on the outside, everybody in here is a base, okay? So it all depends on which exponent you look at to determine who is the base. So 3 different factors here, 2x, y. 2 has an exponent 1. So when my outer exponent distribute its power through multiplication, then my 2 will now be 2 squared. My x will be to the negative 6th power. My y will be to the 8th power, okay, coming out of the parenthesis. So since the base x has a negative exponent, that will flip to the other side of the fraction, because right now everybody is sitting on the numerator over 1. So 2 squared is 4, remain on top. Y to the 8 remains on the top, over x come to the bottom, become positive 6th power. All right. Let's review your rational exponents. Rational exponent says for any real number base a to the m over m power. So rational exponent means my exponents are not fractions. Okay. All the other exponent I've been showing you are integers. All right. For any real number a to the m over n, fraction exponent convert into a radical. So that becomes, and the denominator of the fraction exponent determines the roots. The numerator tells you that the base is raised into that power in the inside the radical, or it can be, or that m can be on the outside of the entire radical to the m power. You can write either way, depends on what the problem is asking. All right, so simply I want to convert this x to the 2/3 power into a radical expressions. So very important concept here, because every time when we see a fraction exponent, automatically that becomes a radical. So x to the 2/3 power, denominator 3 determines the roots. So I have a cube root. The numerator tells me my base x is raised to that power in the inside. So that would be my answer. All right. Now for the negative exponents, for the negative rational exponents, we're simply just gonna flip the base to the other side of the fraction and make the exponent positive, just like the regular negative exponent rules. Okay. All right. I think that's it for this quick review on the exponent rule. So we will talk more about the exponent rules as we go along this semester in this class. And thank you for watching.